Hey kids, it's another installment of parabola stuff. So we're looking at lesson 4.5 today. We're going to look at how you can turn those pesky parabolas into a nice vertex form if they're not already in it. So let's have a little look here. I'm going to share my screen. Okay, so the lesson here is pretty straightforward and it's not going to require much of an introduction. You can see from the title we're going to look at how to write quadratic functions in vertex form. So this is going to be really handy if you've got something that's not in the nice form of a vertex form. We're going to look at how you can do that. So real quick here, we're just going to have a look. Forms of quadratic functions, the two common ones you've seen so far, just as a quick recap. General form looks like this, ax squared plus bx plus c. Vertex form looks like this. The whole deal with the general form is it doesn't give any information about the vertex. It tells you some nice things, but it doesn't tell you anything about where the vertex is. So it's going to be really handy to convert it to vertex form. And you're going to want to do this most of the time when you're graphing. So what we do is we look at that. We complete the square. This never actually goes away in this course, which is just fantastic. So if you forgot how to complete the square, that's what today's mostly about. One thing I'm just going to mention here, you can see because these are side by side, A is the same for both, and that's really worth paying attention to. B and C have some effect on P and Q, but it is certainly not an obvious way. We'll look at some ways that you can figure out B and C from P and Q or vice versa, but it certainly isn't obvious right now, and we'll not focus on that for the moment. Okay, so completing the square, we're just going to look at this. Convert y equals 3x squared minus 12x plus 7 to vertex form. One thing we're going to say is this process is really similar to before. Since we aren't having a left side equal to 0, we're going to have to deal with a little differently. If you remember from way before, we just divided everything by 3 to get rid of that leading coefficient. When this was a 0, then there was no problem because 0 divided by 3 is 0. But if we just divide by 3, we're going to have this guy disappear. But now we're going to have y over 3, and that's not something we want. So instead of dividing everything by 3, we're actually going to do something a little similar, but just tiny bit different. What we're going to do is we're going to factor a out from the first two terms only, and then we're going to leave c on the same side. So we're not moving c to the other side. We're not dividing by a. We're just factoring it out. Very similar ideas, but just a little different in how they're executed. So, oops. Okay. Why don't we actually take a sec here and let's look at this. So step one. Maybe I won't rush ahead. All right. Let's do step one here. If you're actually going to factor out the 3, you're going to take it out from the brackets. First two terms only. So 3x squared and negative 12x will go in the brackets, and that plus 7 is actually going to stay here on the outside. So that's the form we want to get it in. We're not really getting rid of a, but we're certainly making it so that it's not directly in front of that x squared, because that's going to be bad. Okay, so we've got this. Once we have it in this form, now we can move on to the next steps. So we're going to add and subtract b over 2 squared. So this is the same thing we've been doing all along. We've got y equals 3x squared minus 4x. We're going to be adding and subtracting b over 2 squared. We're going to do it in the brackets. This is really important that we do it in the brackets. So if we're looking at this term right here, we can see b is equal to 4. So b over 2 squared is equal to 4 over 2 squared, which, well, that just happens to be 4. So we're going to add 4, and we're going to subtract 4 in those brackets. That plus 7 just hangs out there. What we do is we take the negative term outside the brackets, and we do that by multiplying it by a. So the whole deal with this guy out front is when a 3 is out in front of the brackets, that means the 3 is multiplied by every term inside. If I want to take something out of the brackets, which I do in this case, I have to do that by multiplying the 3 into the last term there. So I'll just show here. This is what we have. plus 4 minus 4. And I'm just going to be multiplying the 3 in with the last guy. I don't want this here. It had to come along for the ride, but I don't actually want it in the brackets. So by doing this multiplication, these guys are going to stay put. But now 3 times negative 4, it actually comes out as negative 12. And then that plus 7 was always just hanging out there. Now I can see this is simplified down to this business. Negative 12 and 7 makes negative 5. Well, I'm getting way ahead of myself here. I guess we can finish this up. So what we can do now is we can collapse this down into its perfect square trinomial. X squared minus 4x plus 4 is just x minus 2 all squared. And we wind up having this guy here. Thought there was another step, but I guess I was just supposed to do it right here. Okay, so that's actually it. The process is really simple if you have completed the square a whole bunch. This should not be too hard. The big thing you have to remember is that our a value, the 3, cannot divide it. You have to factor it out. And when we are taking that number out of the brackets, which we have to do, we got to multiply the 3 back in with it. Okay, so verifying. Once you've completed the square, it's a good idea to maybe check your answer. If you expand this vertex form out, you should get back into the general form. So what we had here was 3 times x minus 2 squared minus 5. So I'm actually going to do that. Y equals 3x minus 2 squared minus 5. So if I verify this, what I'm going to do is I'm going to expand. So if I actually expand this out, I would have 3. You have to do the foiling first. So as we know, if you foil this, I'm going to multiply the 3 into everything here. I'm going to get 3x squared minus 12x plus 12 minus 5. And if I put this all together, I'm going to have 3x squared minus 12x plus 7. Is that what we started with? Let's just take a second, just jump back. 3x squared minus 12x plus 7. That sounds really familiar. So there we go. We verified it. That means we have completed the square and we've expanded it to get back to where we were. Now, don't get confused. You're not going to be expanding every time you complete the square. This is just a verification process. Most of the time, we're not going to re-expand it out, but it's a way you can check your work. Okay, so let's have a little example here. So the whole point of this is that sketching a graph of this guy is actually quite hard unless you do a table of values, and we don't actually want to do that all the time. So the way we can sketch a graph of this is by turning it into vertex form. So the little note here, easiest to convert to vertex form. So what we're going to do here is we're going to convert this guy. And the way this works is same steps. So you've got a leading coefficient of negative 2, and you don't want that there, so you have to factor it out. You factor it out from the first 2 terms only. So when you factor it out from the first term, you're going to get x squared. When you factor it out from negative 3x, the way you factor out negative 2 is you imagine what is negative 3x divided by negative 2? That's going to be plus 3 over 2x. Close up the bracket. This 5 is on the outside. We don't want it included. Okay, now we've got to do the old b over 2 squared deal. So we can see that b is this guy over here. It's 3 over 2. So this is 3 over 2 over 2 squared. That's the same thing as 3 over 4 squared. So that's 9 over 16. So what we're going to do is we're going to go negative 2 x squared plus 3 over 2x plus 9 over 16 minus 9 over 16. You should always do the plus first and then the minus second. Okay, the way we take that out is we're going to now multiply negative 2 by this term here. So multiply. And then what we will have is we will have negative 2 x squared plus 3 over 2x plus 9 over 16. Negative 9 over 16 multiplied by negative 2, that's going to become positive The 2 and the 16 will cancel, and you'll have 9 over 8. And then you've got 5 out here. All right, so we're going to have to do some common denominator stuff. In fact, you know what? Forget that. I'm just going to write this as 40 over 8. So that's easier for me later. So this is negative 2. I'm going to collapse this whole thing down. This is a perfect square trinomial. So this becomes x plus, and what I have to do, remember this number here, there's two ways of looking at it. It's either half of this guy or it's the square root of this guy. Same thing. And if it's not the same thing, you screwed up. Okay, we've got this, and we've got, let's see, 9 over 8 and 40 over 8, so this will be plus 49 over 8. All right, these aren't great numbers, but what we can see is we've got a vertex located at negative 3 over 4. Oops, let's not close that up yet. And 49 over 8. So this is approximately, let's see, negative 0.75, comma, what's 49 divided by 8? That's, I think, 6.125, if I'm not mistaken. 48 divided by 8 is 6, so I think that should work. Okay, so sketching a graph. I didn't include a grid for myself, so I guess I'm just going to have to do this here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 5, 1, 2, 3, 4, 5. Okay, so let's just try something like this. So the vertex is going to be located at negative 3/4 and 49 over 8. So I'm going to put that right about here. And the vertex, negative 3 over 4, and it's about 6.125. And it's going to open up downwards, right? It's a downward parabola, it's a sad parabola, and it's got a vertical stretch of 2. So what I'm going to do is I'm going to move over 1 and then down 2. So from here I'm going to go 1, 2, and this is just a sketch, so it's not going to look perfect. I'm going to go over 1 and down 2, so it's probably somewhere around there. I'm going to go over 2, and normally I'd go down 4, but I'm going to go down 8, so it's going to end up somewhere around here. Whoops, somewhere around there. And then the other one's going to go over 2, so it's going to go 1, 2, and down about 8. Right now, I'm not super concerned about the exact locations of the intercepts, although it wouldn't be a terrible idea to find those, just to check if we're correct. By the way, do I have everything good here? I have a y-intercept. Do I know what my y-intercept is? Well, congratulations, you actually do. That's your y-intercept. So I can tell the way I drew my parabola is not actually super fantastic. The y-intercept is at y equals 5. It kind of looks like I put it in at 6. That wasn't really my intention. So the parabola is actually lower down, something like that. So you can read off the general form of the y-intercept. That is the one strength of the general form. And what are the x-intercepts? Well, the x-intercepts, we can see they kind of look around like 1 and negative 2 and a bit. The way we could solve that is we could set y equals 0, and I'll just do that just because I think it's worth showing. If we set y is equal to 0, you can set it 0 in the general form, or you can set it equal to 0 in the vertex form, and whichever way you want to go is fine by me. I personally think it's a pretty good idea to use the vertex form, because if you actually do this, you can write 0 equals negative 2 x plus 3 over 4 squared plus 49 over 8. I can take this guy to the other side. Didn't really leave myself enough room, so I might have to just kind of cram this in. And I'm going to divide both sides by negative 2, so that's going to be 49 over 16 equals x plus 3 over 4 squared. This is kind of interesting because I'm actually seeing an interesting result here, where if I square root both sides, 49 over 16 actually becomes plus or minus 7 over 4. Then the other side is x plus 3 over 4. So what this is looking like, x is equal to, let's see, we'll move the 3 over 4 there, plus or minus 7 over 4. So what are my answers? When I add 7 over 4 to negative 3 over 4, that's equal to 4 over 4, which is 1. And if I subtract it, that's equal to negative 10 over 4 or 5 over 2. Does that actually look like what I sketched? Well, there's 1. And that actually looks like 5 over 2. That's 2.5. That actually looks like that's about right. So that's a good oral confirmation. Anyway, there's my graph. Okay, here's one more question. Determine the range of this parabola. Again, if it's in general form, this tells you nothing about the range. Yeah, that's the y-intercept, but I don't know if my graph hits here at 5 and swoops like that, or does this sort of thing, or maybe does this sort of thing. I actually have no idea, really. I can look at this 1/2, and I know it opens up, but let's get the vertex form, and we'll get it exactly. So, again, converting to vertex form means factoring out 1/2 from the first two terms. So factor 1/2 out of the first two terms. Okay, so when I factor out 1/2, I'm dividing each term by 1/2. Dividing by 1/2 is like multiplying by 2. So this middle term actually becomes negative 12x. And then the 5 is here. So b over 2 squared, well, if 12 is b, then b over 2 is 6. 6 squared is 36. Minus 36 plus 5. Okay, so this is going to become 1/2 x squared minus 12x plus 36. And I'm going to multiply 1/2 by negative 36 here, so it's going to come out of the brackets, it's negative 18. And then the plus 5 is there. 1/2 x minus 6 squared, and this is going to become negative 13. What this tells me is my vertex is at 6 comma negative 13, and it opens up. Again, the reason I know it opens up is because I can see that this guy right here is what tells me it's opening up. So my parabola is going to look something like this. It's going to be at 6 and negative 13, so that's like way down here, just kind of roughly sketching, and it's going to open upward. So what I can therefore conclude is my range is y is everything greater than or equal to negative 13. Okay, just for fun, why don't we take a second and look at it on Desmos and make sure everything's all good here. So I'm just going to try and remember this. 1/2 x squared minus 6x plus 5. I'm going to go to Desmos. Hopefully I can find it. There we go. I have a window open for it. Of course I do. So 1/2 x squared minus 6x plus 5. So what I can see here is my parabola is right there, and the vertex is, lo and behold, 6 and negative 13, and it opens up, so the range is everything bigger than or equal to negative 13. Okay, so I think that is pretty well it. This is definitely just a routine sort of thing. Practice it the same way you've practiced completing the square, and use it to make those beautiful parabolas amazing. One last thing just for you to think about. I did say there's a way of going from B and C to P and Q. There is a method in doing this. I'm going to leave that for you to think about. One thing I would suggest is if you want to figure this one out, try completing the square without, doesn't even say square, without numbers. Try it on this bad boy and see what happens. It looks intimidating, but it's really not. Follow all the steps and see if you can figure out this conversion here. And this is actually a pretty handy tip. At some point I might let you in on it, but for now I'd like to leave that as something for you to try. Okay, so anyway, that's it. Thank you. Goodbye.